Senior xenoclimatologist Tark stared at the holographic projection with growing frustration. The blue-green planet rotated slowly before him, white swirls of cloud formations dancing across its surface in chaotic patterns that defied every predictive model his team had developed. "Run it again," he ordered, mandibles clicking in agitation. "There must be a variable we're missing." His assistant, Lim, bobbed her eye stalks in acknowledgement, but couldn't hide her skepticism. "This is the 57th Simulation Director. The weather patterns on this planet, Earth, they call it, continue to defy our most advanced meteorological algorithms." The Galactic Survey Corps had tasked Tark's team with assessing Earth's habitability, now that humans had achieved faster-than-light travel and petitioned to join the Galactic Confederation. Standard procedure required thorough environmental analysis of any potential member world. "Perhaps we should present our findings as they stand," suggested Lim. "The Council is expecting our report in 3 rotations." Tark flicked his antennae. "In the negative." "Impossible. They'll think we're incompetent. No natural weather system behaves this way. Look at these storm formations. They develop and dissipate with no discernible pattern. The atmosphere shifts between states that should be mutually exclusive." "Could their technology be responsible?" asked Nev, the junior analyst. "Perhaps they're terraforming or conducting atmospheric experiments." Tark considered this. "Possible, but our scans detect no large-scale weather manipulation technology. Their climate control systems are primitive at best, localized and inefficient." The hologram zoomed in on a massive spiraling storm over an ocean. Humans called these hurricanes. According to their models, this particular storm should have weakened as it approached the landmass. Instead, it intensified. "Document everything," Tark decided. "We'll present the Council with our analysis. Earth's weather patterns cannot be naturally occurring. They must be artificially manipulated, though by means we cannot detect." Later that evening, as the 3 xenoclimatologists finalized their report, an encrypted communication arrived from the advanced diplomatic team on Earth. Lim read it aloud, her voice gradually shifting from professional to incredulous. "The humans claim their weather is entirely natural. Preposterous," Tark exclaimed. "They must be concealing their atmospheric control systems. Perhaps," Nev ventured cautiously, "they simply evolved on this chaotic world and consider such unpredictable weather normal?" Tark dismissed this with a wave. No intelligent species could evolve under such conditions. Random temperature fluctuations, unpredictable precipitation, atmospheric disturbances that destroy their infrastructure. It's not conducive to developing civilization. "Yet they have," Lim pointed out. "And they seem remarkably adapted to it." "Then they're either hiding something," Tark responded, "or their very existence defies everything we understand about evolutionary climatology." The report was submitted with Tark's primary conclusion. Earth's weather systems were almost certainly artificial, designed to appear random, but actually controlled through means beyond current Confederation detection capabilities. He recommended caution in admitting humans to the Confederation until they revealed the truth about their planetary engineering. 2 cycles later, the Confederation Council summoned Tark's team to defend their findings before a special committee that included human representatives. The proceedings would be broadcast across thousands of worlds. Tark felt a mixture of professional pride and nervous anticipation. Soon, the humans would be forced to reveal their weather-controlling secrets, or be exposed as attempting to join the Confederation under false pretenses. Either way, his team would make xenoclimatological history. The Confederation Council chamber hummed with anticipation. Representatives from over 300 species filled the tiered seating, their murmurs creating a symphony of clicks, whistles, and rumbles. At the center of it all stood Tark, his formal presentation robes rustling as he manipulated the holographic controls. "Distinguished council members," he began. "My team has conducted exhaustive analysis of Earth's atmospheric conditions. Our conclusion is unequivocal. Their weather systems cannot be naturally occurring phenomena." The hologram displayed a side-by-side comparison between Earth and Halex III, a terraformed planet with engineered weather. Note the similarities in pattern complexity, but observe the crucial difference. Halex III's weather follows predictable algorithms. Earth's does not. It appears random but achieves a planet-wide homeostasis that has remained stable enough for complex life to evolve. This suggests sophisticated hidden technology. The human delegation, seated at a special observer's podium, exchanged glances. Their lead representative, Dr. Jack Reed, a meteorologist from the North American Union, looked more amused than concerned. Council Speaker Vorn, a massive crystalline entity, vibrated slightly, their species equivalent of clearing a throat. We shall hear from Earth's representatives on this matter. Dr. Reed approached the central platform. His casual demeanor contrasted sharply with Tark's rigid formality. "Thank you, honored Council and Director Tark," he began. "I've reviewed your impressive analysis and I understand your confusion. Earth's weather is indeed complex, but I assure you, it's entirely natural." Tark's antennae quivered with indignation. "Impossible. Our models are based on planets with fewer variables," Reed completed for him. "Earth has a unique combination of features: a large moon, tectonic activity, extensive oceans, and a tilted axis creating seasons. These interact in ways your models haven't accounted for." Reed gestured, and the hologram transformed to show Earth's internal structure, oceanic currents, and atmospheric layers. "Our weather emerges from these interactions. It's chaotic, but follows physical laws. We've spent centuries studying it, and still can't predict it perfectly beyond a few days." Murmurs rippled through the chamber. Tark stepped forward. "If what you say is true, how could intelligent life evolve amid such chaos?" he challenged. "Unpredictable weather patterns would disrupt agriculture, settlement, and technological development." Reed smiled. "It wasn't easy. Our history is full of adaptations to weather extremes. But that very challenge shaped us. We built shelters against storms, developed irrigation for droughts, and created technologies to predict weather patterns. The challenge of our chaotic climate pushed our species to innovate." Counselor Zenk, a methane breather from the outer systems, interjected. "Are we to believe that humans thrive not despite but because of these conditions?" "Precisely," Reed answered. "When you live on a world where conditions can change radically within hours, you learn flexibility, redundancy, and resilience. These became defining human traits." Tark noticed the council members' reactions ranging from skepticism to fascination. He needed to regain control of the narrative. "Perhaps," Tark conceded, "but our scans detected anomalous energy signatures in your upper atmosphere that suggest artificial interference." Reed nodded. "Those would be our weather satellites and research stations. We monitor our weather closely, but we don't control it. We merely try to predict it." "Then explain," Tark pressed, "how your civilization survived events like these." The hologram displayed historical footage of devastating hurricanes, blizzards, and floods. Reed's expression turned solemn. "We didn't always survive. These disasters cost lives and resources, but each time we rebuilt stronger, learned more, and developed better warning systems." As the debate continued, Lim noticed something peculiar about the council members. Many were leaning forward, captivated not by Tark's meticulous data, but by Reed's stories of human resilience against atmospheric adversity. The narrative was shifting, and not in their favor. The council session extended into its second day. Tark had spent the night cycle revising his arguments, determined to prove that humans were either lying or dangerously ignorant about their own planet. "Council members," Tark began the morning session, "I present new evidence." The hologram now displayed a time-lapse of Earth's climate history. "Note these dramatic shifts in global temperature over relatively short periods. Such rapid changes cannot occur naturally without causing mass extinctions." Dr. Reed nodded respectfully. "What you're showing is indeed concerning, but actually supports our position. These are climate anomalies we call El Niño and La Niña events, caused by oceanic atmospheric interactions. They demonstrate precisely how our natural systems operate." A council member with multifaceted eyes, Representative Chell from the aquatic worlds, interjected. "These oscillations, they appear almost rhythmic, yet with variations. Our ocean worlds experience similar phenomena, though less extreme." Tark hadn't anticipated support from the water worlds. He rapidly adjusted his approach. "Even if these specific patterns are natural," he countered, "consider Earth's temperature record over the past millennium. The acceleration of warming exceeds any natural model." Reed's expression grew serious. You've identified what we call climate change, partially caused by our own industrial emissions. It's not artificial control, it's unintended consequences of our development that we're now working to mitigate. The admission of planetary-scale environmental damage caused a stir among the council. Tark sensed an opportunity. You admit to accidentally altering your planet's climate, yet claim no ability to control it? This contradiction suggests deception. For the first time, Reed appeared genuinely irritated. Director Tark, there's a vast difference between inadvertently disrupting natural systems and possessing the technology to control them. We affected our climate through ignorance before we understood the consequences. That's hardly evidence of weather-controlling capabilities. Another human from their delegation stood, an older woman introduced as Dr. Helen Torres, specializing in extreme weather events. If I may, she requested, receiving the speaker's acknowledgement. What puzzles Director Tark is precisely what fascinates us about Earth's systems, their beautiful complexity. Our weather emerges from millions of interactions between sun, land, water, and air. We can influence these systems indirectly, but cannot control them with anything approaching precision. She manipulated the hologram to show mathematical equations. These are our most advanced weather prediction models. They incorporate quantum computing and still fail beyond 2 weeks with any reliability. If we possessed weather control technology, wouldn't we prevent the disasters that kill thousands of our people annually? Tark noticed several council members nodding. The humans' argument carried a certain irrefutable logic. Why would they allow destructive weather if they could prevent it? During the midday recess, Lim approached Tark in the preparation chamber. Director, she said quietly, I've been analyzing the human meteorological databases they provided. Their mathematics of chaos theory and complex systems are remarkably advanced, possibly exceeding our own in this specific domain. What are you suggesting? Tark asked sharply. That perhaps we've approached this backward. Rather than assuming their weather is artificially controlled to appear natural, what if their understanding of natural complexity surpasses ours because they evolved on a world defined by it? Tark stared at his assistant, his professional certainty wavering for the first time. Before he could respond, they were summoned back to the chamber, where the council had reached a preliminary decision. Speaker Vorn's crystalline form glittered as they announced, "We shall dispatch a joint scientific expedition to Earth for direct observation. Representatives from both the Confederation's Sciences Division and Earth's meteorological authorities will participate. Until then, judgment is reserved." Tark realized with sinking certainty that his reputation now hinged on what they would find on humanity's chaotic homeworld. The research vessel Atmospheric Inquiry entered Earth orbit exactly 15 rotations later. Tark stood at the observation deck, watching the swirling cloud patterns below with professional fascination and personal dread. This mission would either vindicate his theories or destroy his reputation. "Preliminary scans complete," reported Nev, who had been promoted to full analyst for the expedition. "The humans have granted us access to their global weather monitoring network. The data integration is remarkable." Tark joined him at the monitoring station. Earth's meteorological surveillance system was indeed impressive. Thousands of ground stations, ocean buoys, atmospheric drones, and satellites, all feeding data into predictive models. Sophisticated, Tark admitted, but still monitoring, not controlling. Dr. Reed entered the deck, accompanied by several human scientists. "We'll be making planetfall in the region called Oklahoma tomorrow," he announced. "It's tornado season there. An excellent opportunity to observe some of our most extreme weather formations in person." "Tornadoes," Lim repeated, consulting her datapad. "Violently rotating air columns with wind speeds exceeding 300 kilometers per hour. Why would you deliberately expose us to such phenomena?" Dr. Torres smiled. "Because seeing is believing. You can monitor a tornado from orbit, but understanding its raw power requires proximity. Don't worry. We've developed excellent prediction and shelter systems." The next day, the expedition team descended in a shuttle to a facility called the National Severe Storms Laboratory. The air was thick and humid, the sky a peculiar greenish-gray that made Tark's skin membrane tingle uncomfortably. "Barometric pressure is dropping rapidly," Dr. Reed explained, examining instruments with practiced ease. These conditions are perfect for supercell formation. Within hours, Tark found himself inside a heavily reinforced vehicle called a storm chaser, racing across flat plains toward immense, anvil-shaped clouds that seemed to defy gravity. The humans' excitement grew as the storm intensified, their instruments capturing every fluctuation in temperature, humidity, and wind direction. "There!" called out Dr. Torres, pointing toward a rotating wall cloud. "Watch carefully." Tark watched in horrified fascination as a funnel cloud descended from the storm base, touching down several kilometers away. The thin, violent vortex carved a path across the landscape, its roar audible even at this distance. "Magnificent F3 formation," commented one of the human meteorologists, capturing readings with evident professional satisfaction. "You find this magnificent?" Tark asked incredulously. "That vortex could destroy your dwellings, your infrastructure." "It could," Reed agreed, "and sometimes does. But understanding these storms helps us predict them better. Every data point improves our warning systems and saves lives." For 7 Earth days, the expedition team chased storms across the Central Plains, documented flash floods in coastal regions, and monitored blizzard conditions in northern territories. Everywhere they went, Tark observed humans not controlling weather, but adapting to it with remarkable ingenuity. In the Antarctic Research Station, studying historical ice cores, Tark finally conceded the point to Lim privately. "Their weather truly is natural," he admitted. "Chaotic, extreme, unpredictable, yet they've thrived within its constraints. It's humbling." Lim's eye stalks drooped slightly in sympathy. "The Council will expect our revised report soon. What will you tell them?" Tark stared out at the endless, white landscape, where humans maintained a research base in conditions that would kill most Confederation species in minutes. "The truth," he replied. "That we underestimated both Earth's natural complexity and humanity's remarkable adaptation to it, and perhaps that there are things our own climate science could learn from theirs." As he prepared his preliminary findings that night, Tark began to realize that the most remarkable thing about Earth wasn't its weather. It was the species that had evolved to not just survive it, but to study, understand, and respect its untamable power. The storm sirens wailed across the Kansas Research Station on what was supposed to be the expedition's final day on Earth. The metallic taste of ozone filled the air as dark clouds massed on the horizon. Category 5. Hurricane making landfall in Florida, record blizzard in the Rockies, and now this, muttered Tark, checking the alert on his datapad. "Does your planet ever experience calm weather?" Dr. Reed laughed. "Sometimes we get a few nice days in spring." The emergency broadcast system interrupted with an urgent message. A derecho event, a widespread, long-lived windstorm, was developing rapidly. Evacuation orders had been issued for several counties. "Change of plans," announced Dr. Torres. "We're being redirected to the Emergency Response Coordination Center in Kansas City. The governor has approved your observer status." Hours later, Tark and his team watched in fascination as humans mobilized to face the approaching storm front. The response center hummed with activity, meteorologists tracking the storm's path, emergency managers coordinating evacuations, infrastructure teams preparing for power outages. "Your species dedicates enormous resources to weather response," observed Lim, reviewing their protocols. "On Confederation worlds, we would simply adjust the atmospheric conditions to disperse such storms." "That luxury isn't available to us," replied Maria Lopez, the center's director. "Instead, we've developed prediction, preparation, and recovery systems. This storm will cause damage, that's inevitable. Our job is to minimize casualties and facilitate rapid recovery." Tark found himself assigned to an emergency team alongside Dr. Reed. As they helped secure a hospital's backup generators, the sky darkened prematurely. The wind rose from gentle breeze to howling gale within minutes. "This is what we don't capture in our models," Tark shouted over the wind. "The sheer variability, the rapid transitions." Reed nodded, rain streaming down his face. "Exactly. Earth's weather doesn't just exist as data points. It's experienced, it's felt. That's what shapes cultures, architecture, agriculture, everything." The storm raged through the night. Tark witnessed both destruction and immediate human response. Teams clearing fallen trees from roads, restoring power lines, providing temporary shelter. By morning, reconstruction had already begun. During the cleanup efforts, Tark interviewed dozens of local residents. Their attitudes toward weather varied dramatically. Farmers who depended on rainfall patterns, urban dwellers concerned about flooding, elderly citizens who felt storms in their bones before meteorological instruments detected pressure changes. "Your species has developed a relationship with your weather," Tark observed to Dr. Torres as they helped distribute supplies at a community center. "Not control, but something more symbiotic." Torres considered this. "That's an insightful way to frame it. We can't control the rain or wind, but we've learned to read the signs, to prepare, to build with weather in mind. It's shaped our psychology too. We understand that some things cannot be controlled, only endured and adapted to." That evening, as the expedition team prepared their final reports, a message arrived from the Confederation Council. In light of the ongoing weather events, their mission was extended by 7 days. They were to document how humans recovered from natural disasters. "They still suspect artificial manipulation," Lim surmised, reading between the lines of the directive. "No," Tark replied, surprising his team. "I believe they're genuinely curious now. The Council has reviewed our preliminary data and found something unexpected. A species that achieves technological advancement not by conquering their environment, but by dancing with its chaos." As they continued their extended mission, Tark began documenting not just weather patterns, but human resilience patterns, community mutual aid networks, infrastructure redundancy systems, architectural adaptations specific to regional weather threats. "Your buildings in tornado zones have underground shelters," Nev noted during a community reconstruction project. "Coastal structures are elevated for floods, northern dwellings insulated for cold. Each design evolved for specific threats." "Necessity drives innovation," explained a local engineer helping them. "When you can't change the weather, you change how you live with it." Tark found himself revising his report yet again, this time focusing on a revolutionary concept. Perhaps Earth's weather, in all its chaotic glory, wasn't an obstacle to human advancement, but a catalyst for it. The question was no longer whether humans were truthful about their weather, but what the Confederation might learn from their adaptive relationship with natural forces. The Confederation Council chamber fell silent as Tark concluded his presentation. The holographic display showed time-lapse imagery of Earth's weather systems. Hurricanes spiraling across oceans, jet streams undulating around the planet, and cloud formations blooming and dissipating like living organisms. "Distinguished council members," Tark said, his voice steady despite his nerves. "My team entered this investigation convinced that Earth's weather patterns must be artificially controlled. We were wrong. Earth's atmospheric systems are indeed natural and far more complex than our models anticipated." He gestured to the human delegation, where Dr. Reed and Dr. Torres sat among their colleagues. "Furthermore, humanity's adaptation to these conditions represents an evolutionary and technological path distinct from any Confederation species. They don't control their environment. They understand and respect its power." Speaker Vorn's crystalline form shimmered. "Your revised assessment is noted, Director Tark. This represents a significant reversal of your initial position. Are you certain of these conclusions?" "Absolutely," Tark replied without hesitation. "My team experienced Earth's weather systems firsthand. We observed 7 major weather events across different regions. The evidence is irrefutable. Humans have achieved technological advancement not by manipulating their environment, but by adapting to its extremes." Councillor Zenk leaned forward. "If their weather truly is natural, this raises profound questions about environmental determinism across the galaxy. Could such chaotic conditions actually accelerate certain evolutionary pathways?" "The data suggests precisely that," Lim responded, stepping forward. "Humans developed complex problem-solving abilities, social cooperation structures, and technological innovation specifically because they could not control their environment. This contradicts our established xenodevelopmental models." The Council chambers erupted in discussion. Species from stable environments expressed skepticism, while those from more variable worlds nodded in recognition. Dr. Reed was invited to address the Council. "Earth's weather has shaped everything about us, our bodies, our societies, our technologies. We built our first shelters because of rain and snow. We developed agriculture by studying seasonal patterns. We sailed across oceans by learning wind, currents. Even our earliest mythologies centered around weather deities. Yet now you possess technology capable of space travel, observed a council member from the methane-based Dorvo collective. Could you not have developed weather control? Instead, we've considered it, Dr. Torres acknowledged. Local cloud seeding, hurricane mitigation experiments, atmospheric carbon capture. We've attempted limited interventions, but full weather control would require energy expenditure greater than our entire planetary output, and would likely create cascading ecological consequences we cannot predict. Tark added, their scientific models suggest that even with advanced technology, complete weather control on a planet with Earth's complex systems would be prohibitively costly and potentially destabilizing to natural ecosystems. As the session continued, a new narrative emerged, one that framed Earth's chaotic weather not as a liability, but as a unique developmental environment that had produced a remarkably adaptive species. During a recess, Tark found himself approached by representatives from the Confederation's Sciences Division. Your team's revised findings are causing quite a stir, said Director Molo, a senior scientist. Some are suggesting we've been approaching planetary development backward, that perhaps introducing weather stabilization to developing worlds isn't always beneficial for species evolution. Controversial, Tark acknowledged, but the human example is compelling. Their weather drove them to develop sophisticated predictive mathematics, resilient architecture, and decentralized infrastructure. These innovations now benefit them in space exploration and potential colonization efforts. Later that evening, at a reception for the Earth delegation, Tark overheard various council members discussing the implications. Some worried about human unpredictability. A species forged by chaos might carry that chaos with them. Others were fascinated by human adaptability, a valuable trait for potential Confederation allies. Dr. Reed found Tark on an observation deck, watching Earth's image projected among the stars. Your report was more generous than I expected, Reed admitted. When we first met, you were convinced we were hiding planetary engineering technology. Scientific integrity demands following evidence, not assumptions, Tark replied. Though, I admit, it was difficult to accept that a species could advance technologically while remaining so vulnerable to natural forces. Perhaps that's our greatest strength, Reed suggested. We never developed the illusion of control that comes with weather engineering. We know we're at the mercy of greater forces, and that knowledge keeps us humble, innovative, and prepared for the unexpected. As they conversed, news arrived that the Council had voted to establish a joint Earth Confederation Climate Research Institute, with Tark appointed as co-director alongside Dr. Torres. Their mission, to study whether controlled environmental randomness might actually benefit developing worlds rather than hinder them. The paradigm was shifting. Earth's chaotic weather, once viewed as evidence of hidden technology or a developmental handicap, was being reconsidered as a powerful evolutionary catalyst. 5 years after Earth joined the Confederation, Tark stood on the observation platform of the newly constructed Planetary Climate Dynamics Institute. The massive facility, built in Earth's Rocky Mountains, housed the most advanced weather modeling systems in the galaxy, a collaboration between human meteorologists and xenoclimatologists from 27 member species. Simulation complete, announced the central AI system. Projected evolutionary outcomes display significant divergence based on environmental stability parameters. The holographic display showed parallel development tracks for an aquatic species, from Eridani 4, one group evolving under stable, engineered weather conditions, the other facing the planet's natural meteorological variations. After 5,000 simulated years, the difference was striking. The population experiencing weather challenges had developed more complex social structures, more varied technological solutions, and greater neurological adaptation capacity. The Earth hypothesis continues to demonstrate validity across multiple test cases, noted Lim, now Deputy Director of Comparative Evolutionary Climatology. Environmental pressure creates adaptive advantages that engineering away may actually inhibit. This research had sparked fierce debate throughout the Confederation. For millennia, member species had assumed that controlling planetary conditions represented evolutionary advancement. The idea that unpredictability might be beneficial challenged fundamental assumptions about progress. Director Tark, called Dr. Torres, entering the observation deck with a delegation of officials. The Confederation Education Council has arrived to discuss implementing weather variability protocols in development zone habitats. The visitors included representatives from worlds that had previously dismissed Earth's admission to the Confederation. Now they came seeking insight from the species that had mastered chaos rather than eliminated it. "We've reviewed your provisional findings," stated Counselor Zept, a silicon-based life form whose species evolved on a tectonically stable world. "The correlation between environmental unpredictability and innovation metrics is concerning. Our development models may require significant revision." As Tark guided the delegation through the Institute's research divisions, he reflected on how dramatically perspectives had shifted. Humans, initially viewed with suspicion for their claims about natural weather, were now sought after as consultants, for their adaptive expertise. In the Applied Technologies Division, Dr. Reed demonstrated how Earth's weather-resistant infrastructure designs were being adapted for colony worlds. "These distributed power systems were developed to withstand hurricanes," he explained, showing modular energy grids that could reconfigure after damage. "But they're equally effective against solar flares, meteorite impacts, or even deliberate attacks. Resilience transcends its original purpose." Later, at the Institute's central garden, a biodome experiencing real-time Earth weather patterns, Tark found himself in conversation with Dr. Miles Johnson, Earth's first ambassador to the Confederation. "When you first accused us of weather manipulation, I thought it was ridiculous," Johnson admitted, watching as a controlled rainstorm watered the garden's earth plants. "Now I understand your confusion. To evolve alongside such atmospheric chaos must seem improbable from your perspective." "Not improbable," Tark corrected, "but exceptional. Your species didn't merely survive your planet's weather extremes. You were shaped by them, strengthened by them. Now we're discovering this pattern across multiple worlds and species." The emerging crucible theory proposed that species evolving under moderate environmental pressure developed greater adaptability than those in either too stable or too extreme conditions. Earth represented an optimal balance, challenging enough to drive innovation without preventing civilization's development. As the Institute prepared for its formal inauguration ceremony the following day, Tark reviewed his opening address. The event would be broadcast across the Confederation and mark official recognition of Earth's contribution to galactic science. His speech acknowledged the journey from accusation to understanding. "5 years ago, I stood before the Council and claimed Earth's weather couldn't possibly be natural. I was correct in sensing something extraordinary but wrong about its nature. The extraordinary element wasn't hidden technology, it was humanity itself, a species forged by forces they couldn't control but learned to understand." The ceremony gathered dignitaries from across the galaxy. When Tark concluded his address, Speaker Vorn presented him and the human scientific team with the Confederation's highest scientific honor for challenging our assumptions about environmental determinism and advancing our understanding of adaptive evolution, the citation read, "and for demonstrating that sometimes the most advanced civilization is not the one that conquers chaos, but the one shaped by dancing with it." As applause filled the chamber, Tark watched Earth's weather patterns displayed on the great dome above. Hurricanes and blizzards, droughts and floods, the endless dance of atmospheric forces that had created not monsters but innovators, not victims but pioneers. The same forces that Confederation worlds had engineered away for millennia had produced humanity, resilient, adaptable, and ready to help the galaxy rethink what it meant to develop in harmony with natural forces, rather than in opposition to them. In the end, Earth's weather wasn't artificial as Tark had initially claimed, but its impact on galactic understanding of evolutionary development was more profound than anyone could have predicted. The storms that had once seemed like evidence against humanity's truthfulness had become their greatest contribution to Confederation science. Sometimes, Tark reflected, the most valuable discoveries came not from confirming our theories, but from having the courage to admit when they were wrong.